In my tutorial, in this stage I am going to show you vector from Cambridge Admit book. It's chapter 13 and chapter name is vector. So step by step I will show all type of questions from here, that the exercises given here. So you may see that exercises, what the definitions are, how to solve some of the questions best. Then you may start from here. Exercise 13.1, page number 318, we are going to show. Write each vector in the form of ai plus bj. That is the first part. So to do all the vectors in that direction, particular direction, we needed to consider this. Say I am going to presenting here, if this is a center, any vector from center to right, if it goes, then we are denoting it as a I in that direction. And if it is from the middle, or if it goes to the left side, then we are presenting it minus j. Sorry, it's not minus j, it's a minus I. It's minus I. And if it is from O, if it is go up, then we are presenting it positive j. If it is goes down, then we are writing minus negative j. That are the total thing of the vector. Let me see the question. First question, AB, from A to B. So we have to move first horizontally, then we will move the vertical direction. So from A to B, we needed to go to first right side, then down this one. So on the right side it goes 1 unit, and the downside it goes 1 unit, 2 unit, 3 unit. So this one downward direction we can say minus j, minus j, minus j. And on the right side, if it goes, it is the I. So we can write the vector in terms of I and j, like I minus 3j, because it goes downward, vertically downward. That's why I plus minus 3j. Let me do the another one, AC. From A to C, we can erase the previous part. A to C, first draw the line. First from A, go to the vertically horizontal direction. From A to C, if we wanted to go, first we needed to go right side, horizontally right. Then to C we have to go down. So how much right we traveled? So here I, then I, then I, 3I on the rightward direction. I already have shown this part is here, and downward 1, 2. So we can express this one 3I minus 2j. That is the, in terms of ij we can express. Let me do one more from here. It is written here AD. From A to D, if we go, I think now we can do alone 1, 2, 3, 4, then j. So we can write it 4I minus j, 1 unit on the downward. Let me move directly to the DC. D to C, if we see the diagram from D to C, if we go horizontally first, then we need to go left side first, which is minus I, then downward also, which is minus j, because we know if it is go upward, then we can express as a positive j. So in terms of ing, if we write it, minus I minus j is the vector in that stage. Let me do one more question from here. G, which is EA, it is written here EA. So EA, it's a horizontal line but goes left side. So directly we can write here minus 2I. But the j, there is no vertical movement here, so we can say minus 2I is its answer. Hope the way we did the question number 1 you understood. Those are saying my tutorial. Now you are welcome to see the second one. It's written here, find the magnitude of each of these vectors. Magnitude is very simple thing. Magnitude is actually they are asking for the distance from A to vector. Say it is written here 4I plus 3j. Magnitude of the vector we actually have to do like this way. I'm going to show the working first. 4i plus 3j. So this is, we are writing with this modular sign. Then inside we have to do 4 square plus 3 square. Why we are doing this? Now the question is 16 plus 9 and it gives us 5. Why we are doing this? Let's see what is the 3i plus 4i plus 3j. If I use the previous diagram, extremely sorry, let me draw the diagram from here. Let me draw it. Say I'm going to mark with the blue color right now. 4i plus 3j. Say we are going to start from B point. 4i means it goes 1 2 3 4 right side. Then 3j means it goes 3 up, 1 2 3. So B, if we denoted that point F, so we can say BF we can express as a 3i plus 4i plus 3j, because it goes 4 right side, 3j. Well, it is actually direct distance from B to F. We are going to apply here the Pythagoras theorem. So 4 square plus 3 square up, that's why it is 4 square plus 3 square. According to the Pythagoras theorem, we can find out the direct of this magnitude. It's the 5 unit we got from there. Let me move another question to D. If both are negative, how to find out the magnitude? The same working, minus 8i minus 6j. Even it is given there both are negative, no problem, but we needed to use the positive one. Minus 8 whole square plus minus 6 whole square is the magnitude also. So this is 64 plus 36, which is root over 100. So we can say 10 is the answer of this magnitude. This is the total working of this question. Similar type workings rest of the question. Let's say one negative, one positive. Question number G, if we select same working again, which is minus 4i plus 4j, and its magnitude is minus 4 whole square plus 4 whole square, which is 16 plus 16. So we can say root 32, which gives us actually 4 root 2 if you use a calculator, because 16 square root is 4, but 2 root 2 is root 2 we have to write. So this is the magnitude. Every part is very important to know to do the question paper actually. Now I'm trying to show you, if there's a parallel vector is given, then how to do the questions, especially in question number 3. Please read the question first. 3 written here, the vector AB has magnitude 20 unit and it's parallel to the vector 4i plus 3j. If any vector's parallel vector is given, so we can write the vector like question 3 we are doing. Vector AB we can express as a, though parallel vector of AB is given 4i plus 3j, if we multiply with a constant, then with the parallel vector, then it becomes the vector, actual vector. This is the main theory. If we multiply with any constant with the parallel vector, that directly it turns to that particular vector. So we can write it 4ki plus 3kj. Now we are going to find out the magnitude of this vector. Magnitude of this vector, the way we did the previous one, we also can apply the same formula, which is 4k whole square plus 3k whole square. This is the magnitude of this vector, and this magnitude is given here 20. We are doing question number 3 from exercise 13.1, page 318 of Cambridge Admit book. We can write the magnitude because we got given value 20. Let me write it 20. Now just simplify and solve it. 4k square plus 3k square, which is 16k square plus 9k square. If we make the square on the both side, it gives a 20 square. So the value coming here 25k square equals to 400. So k square equals to 400 by 25, and it gives us 16. We can write k as a 16 magnitude parallel to the vector unit vector 3a plus 4j. So we can write k as a 4. Square root of the 16 is 4, and it is given here parallel to the vector. We are not taking the negative value because its direction is given. Parallel vector is kind of direction, we can say 4a plus 3j both are positive, so we are keeping the same direction. So AB we got the value vector. We needed to multiply with the 4 with this vector 16. So say 4 into 4i plus 3j. So our final answer is 16i plus 3 4s are 12j. To do that type of question, main theory is if there is a parallel vector is given, we are going to multiply with the constant with this vector to make the actual vector. Then just the condition given, apply that condition, you would get the answer from here. Let's see the other questions from here. Question number 4 is similar type question. I am not going to show here question number 4. Question number 5, find the unit vector in the direction of this. We know the magnitude of the vector, but unit vector is a vector. If we divide with the magnitude of the vector with that particular vector, then we would get the unit vector. Let me show one question from here. All questions are similar type. Unit vector of 5a, we can write 6i plus 8j. We are going to divide with the modulus of this vector or magnitude of this vector, so which is 6 square plus 8 square. It gives us 6i plus 8j divided by 36 plus 64, which is 10. So finally you can write 0.6i plus 0.8j. Actually, property of the unit vector, if we make again modulus of the unit vector, we would get from here 1 only. So this is the property of the unit vector. So let me move to another question. 5c I am going to show right now. It is written here minus 4i minus 3j. We have to divide with the magnitude of this vector, which is minus 4 square plus minus 3 whole square. The negative we have to divide, which is minus 4i minus 3j, and it's we got 16 plus 9 is 25. I think 5 we would get from there, so which we can write minus 0.8i and minus 0.6j, and that is the answer of this question. In this stage I am going to show one more question from this page, which is question number 6. It's also very easy. P is given 8i plus 6j with denoted by P, and Q is minus 2ij plus tj. R is 10i, so they're asking to find out that vector. Say B we are going to find out. It is written here 2P plus Q. Just put the vector values from there, which is 8i minus 6j, and Q vector is here minus 2i plus 3j. Let me remove the bracket. 8 to the 16i minus 12j minus 2i plus 3j we can write from there. So we got from there 16 minus 12 is 4i, and minus 12 plus 3 which gives us minus 9j, and this is answer of that question. Same working for other questions. Let me do the question but D as well. I'm going to D here. Half of, it is written half of R, and R is given here 10i. Let me write 10i. Then minus P is 8i minus 6j, minus Q minus 2i plus 3j. Now remove the first bracket from here. First one gives us 5i minus 8i plus 6j, then plus 2i plus minus 3j. Now we have to add all the values. It is 5i minus 8i, which is minus 3i, then plus 2i written here, so minus 3i plus 2i, which is minus I. Then another part 6j minus 3j, we can write it plus 3j, and that is our answer of this question. Those are actually seeing this chapter first time and middle of the part you joined here. So this is the exercise 13.1, page number 318 from Cambridge Admit book. Thanks for your time and patience to watching my video.